So we've talked about making histograms, and it's technically true that we could have created histograms using discrete data and continuous data. Both are entirely possible. We can do that. But with discrete data in particular, we have another helpful tool that I want to discuss here, and that's a dot plot. A dot plot is similar in that we still get a sense of the distribution of data, but instead all the data values themselves are represented as unique dots. So to motivate that idea, I have here a sample data set of the number of visas. So visas are legal documents that allow somebody to emigrate a country, accepted in a 1 month period at a particular immigration office. This is simulated data, but the idea is this is discrete data. We're really talking about, if number of visas you can accept 0 all the way up to whatever large number is possible. But in this case, what we're specifically looking at is we have a range from 0 to 24, and these are all integers, they're whole numbers. So if we want to create a dot plot, what we can do is we can set up our horizontal axis, and no need to set up a vertical axis. The vertical axis will come into view once we start putting our data. But we want our scale to be accurate, so we'll start at 0, right? And you can go up by 1s, by 2s, by however many. I think I'll just go basically by 1s. I have enough space here for that to be possible. Technically, I'm going by 2s, but I'm only labeling. I'm going by 1s, but I'm only labeling the 2s, right? Now, each data value can be represented as a dot. And so you can put that dot above the line and just go down the line. And every time you get a data value, so I have a 0 here, I'm taking care of that. And the next one is a 0, so I'll stack that above. And so that's that 0 represented. And you just go down the line. Okay, so there were 4 zeros in our data set, and they're each represented by a dot. And you can keep going down in this manner. So it should look kind of like a Connect 4 board, but with all the, a very long one if you have a lot of data value, unique data values. Okay, so 1s, 2s, 3s. Try to be consistent with where you place your dots vertically. So it's not, it's not a hard and fast rule that you have to do, a certain vertical scale, but try to do something that makes sense and is proportionate. 4, 5. Since there's no 6 value, we skip that one over, right? So there's no data value in here that matches 6. We skip it. There's a 7. There's an 8. No 9, 10, but there's 2 11s. Right, and so on. I have 4 14s. And you start to see a picture emerge here of where your data values are represented. 118, 120, and 124, right? So if you could kind of imagine what it, if you wanted to visualize the trend here, it kind of looks like this. Does that make sense? You don't have to draw in the orange curve like I did just now. But a dot plot is really helpful in that you can really immediately see the distribution of your data and it's just as time consuming, I think, as making a histogram, if not less. So I recommend using dot plots as often as you can with discrete data. So of course this begs the question, why can't we do it with continuous data? You can, but if you think about the previous example in previous videos, so if you recall, this was our sample data set, and so yes, you could technically put this on a dot plot if you wanted to, but if you had more fine precision or a much larger data set, you're wasting your time by representing each one of these. And it's actually much more helpful to think about, how many fit into the category of between 7 and 7.9. Whereas with the example we're working with here, it may not make that much sense, right? Why categorize between 0 and 4 or 0 and 5 when you can just, lay them all out plainly to see like this? And so that's the idea behind dot plots. If you had twin data sets, you could, for instance, represent one of them on top and the other one on the bottom, right? So I don't know, it could look like something like this. Right, and now you can compare the two distributions at once, and then color code as often as you can. That would be helpful. And another advantage here is you don't have to set up the frequency distribution, right? You just go straight to the graph. So dot plots, super helpful. Highly recommend for working with discrete data in particular.